Hi, my name is Haodi Wu. The topic I selected was the impact of the house features on the housing prices. With the improvement of the people's income level, there are more and more people consider buying houses as an investment means, whereas there is a symmetry information between buyers and the sellers. Leading consumers have doubt about whether the house matches the corresponding housing prices. For the house pricing, there is no standard in the market, so I want to build a simple norm to help buyers make informed purchasing decisions. I explore the relationship between the 10 independent variables and the sale prices of the houses in King County, USA from the May 2014 to May 2015, and I used RStudio for all my research. Firstly, I built a multiple regression model based on 10 independent variables. In the W week test, we can see that the W value is 0.8, which is very close to the 1. And it means that the data is very close to the normal distribution. Whereas I noticed that the p-value is too small. It indicates the existence of the outliers. So I built an image of the regression model, and it conformed to the normal distribution with a heavily right shift. So I delete the high outliers from the dataset. I then conduct a ANOVA test and the p-value test. According to the ANOVA test result, we can see that the independent variable with stars have a significantly impact on the house pricing. And through these two tests, I delayed 3 independent variables with relative low correlation with the house pricing from the model. I also built a correlation matrix to test the correlation between the independent variable. It also indicated that the deleted 3 variables have low correlation with the other variables. I then used the rest 7 variables to build a new regression model and conduct collinearity tests to test the collinearity between the independent variable, which may affect the explanatory power of the model. I noticed that the VIF value of the living area over than 5. It means that it has strong correlation with the other variables. So I remove it and build the new model 3. The new collinearity test has significantly decreased in all VIF value. Whereas I noticed that the adjust R-square of the model 3 less than model 2. So in order to choose the optimized model, I conduct comparative analysis by using the BIC and ANOVA comparison. According to the BIC, we can see that the Model 2 have a better balance between the fit and the model simplicity. And according to the ANOVA comparison, we can see that the Model 3 have a higher DF and the sum of the square, which means it contains more error than Model 2. So finally, I choose the Model 2 as my final model. And this model can help to address the following issue. Firstly, by quantifying the impact of the multiple features, this model can help the buyer understand the real value of the house and reduce the decision error caused by the asymmetric information. Secondly, this model provides a scientific method to evaluating pricing, offer the buyer and the seller a common reference, and enhance the fairness of the transaction. For the buyer who views the house as an investment means, this model can help them to judge the investment potential of the house. And for seller, this model can use as a reference basis for pricing so that they could price reasonably in the future. Thank you. That's all of my presentation.